Welcome to Walkabout the Galaxy, the hopeful astronomy podcast.
Yes.
Where the science is universal, the opinions are personal, and the hosts are irrepressible. We are Strange Charm and Top the Astroquarks, also known as Josh Cole, Addie Dove, and Jim Cooney, coming to you from the Walkabout studios at the University of Central Florida. Be sure to stick around for the end of the episode to hear us finally shut up.
It doesn't really happen.
Our stumpers are a mouthful. Jim.
Yes, sir.
I'll start with you. See if I can pronounce this correctly.
Probably won't.
I certainly won't.
Probably won't, yeah.
Bremsstrahlung.
That's pretty good.
Or Cherenkov radiation.
This is pretty obscure stumpers today. I'll go.
But not for you.
Not for me, but
because your mind is a steel trap.
My mind is a steel trap, and I remember all of these things. I'm going to go with Cherenkov radiation.
Oh, cool.
Both of them actually have, significant astrophysical implications and are interesting. Those are both.
Well, go ahead.
So they're both types of radiation that we see. So radiation meaning electromagnetic radiation. So they're both light. But it's like the process of producing that light. Or the Bremsstrahlung is like.
So it literally means breaking radiation.
Breaking radiation, right?
And I always used to refer to it as Bremsstrahlung radiation, but that's redundant. That's like calling
ATM machine.
Exactly.
Oh.
Yeah.
PIN number.
I just learned
I think I've done that same thing, yeah.
Yeah. So Bremsstrahlung means breaking radiation.
So that's the radiation let off and like a charged particle slows down because it's interacting with other things. And then
it doesn't need to be interacting with other things in the Bremsstrahlung.
Mm-mm.
Well, otherwise it won't be slowing down.
Oh, okay.
Yeah, I mean, it has to be accelerating. So
okay, touche. Right. Something slows it down, so it has to be speeding up or slowing down.
Right,
yeah.
right. And that has lots of interesting astrophysical things, but I'm not going to worry about it because I'm picking Cherenkov radiation, which is radiation given off by charged particles as they're moving through a material.
Yeah.
And they're moving faster than the speed of light in that material.
This is so awesome.
So which is really cool. Because obviously, we lay down all these rules in relativity how nothing can travel faster than the speed of light, but there's kind of a little asterisk there because the speed of light in a material, like the speed of light in water is like 75% the speed of light in a vacuum.
Yeah.
And things, individual, charged particles may be moving faster than 75% the speed of light in that water.
Right.
And thus they produce this very cool radiation called Cherenkov radiation, which is, I don't know, it's like a...
It is cool. It's the kind of radiation that you will see in a Marvel Cinematic Universe movie.
Yeah.
Right,
or in like a good sci-fi movie. Or,
Yes.
That's right, yeah. When you look at like the reactors, nuclear reactors and stuff like that, there's this blue glow and stuff like that around those that's Cherenkov radiation, and it's pretty cool.
It's legit.
It's legit. It's really
because
cool.
it's charged particles moving through water, just as you were giving an example.
Yeah. Right, moving through water, traveling faster than 75% of the speed of light, and they give off this cool radiation. It's similar to like the bow shock of a boat going through the water. It's this, and I've even heard, I don't know if this is totally true or not, but so like astronauts when they go up into space, they occasionally see these flashes in their eyes.
Yeah.
And it's the idea is that some of those are probably cosmic rays entering their eyeballs,
through the
and then the
fluid
Cherenkov,
in the eye.
and
that is
It's
awesome.
not just
Cherenkov
cosmic ray
radiation.
impacts, it's actually Cherenkov radiation.
It's
on top
Cherenkov
of that?
radiation
in their eyes.
in their eyeballs.
Because the charged particle is going faster than the speed of light through the
In
fluid
the
that's
fluid
in your eye.
Right.
That is so
I
awesome.
want
That's
to do that
pretty cool.
experiment.
Yeah.
I don't know if that's good for your eye, but it doesn't sound.
But you could send a
probably
little
fine.
experiment up to station to
Sure.
simulate a fluid in an eyeball and
Make a
simulate
fake
that.
eyeball.
Yes. All right.
Has
We
nobody
have
done
our
that?
next
And then you
proposal
just have
to
your-
NASA.
Yeah.
Oh.
But yeah. So yeah, I would have to go also. I thought that was super cool when I was looking into it. Yeah. Addie.
Too bad mine stumpers must be boring compared to that.
Well, yours it's a different flavor of our sort of general astronomical spectrum of
I like
things
flavors.
here. Yours, I think I can do a little bit better job pronouncing. Maybe
Okay.
an orthosite
Oh yes.
or basalt.
Yeah, those are rocks. For those who aren't as familiar, those are rocks.
And that's as far as my understanding.
And for most
Extends.
physicists or planetary scientists who have a physics
I think I know what
background,
basalt is, but I don't know. I'm not sure.
Yeah, so basalt is like the material that's produced in volcanic processes, right?
Right.
So most of Hawaii, so the darker lava stuff you think of there is basalt.
Yep.
A northosite is a type of
Rock.
that is not basalt.
Correct.
And it's so, but the reason I like this question is because on the moon, the dark areas are made up of basalt, the mare are basalt, and the light areas, the highlands, are made up of anorthosite.
Oh, that's why
so
you
it's
asked her
the
that.
other,
It
it's the other material that composes most of the moon. And it's a silicic material, also. And
Silicic?
What?
Silicic. It's like
No,
a
no, no.
silicate. Silicates.
Okay. It's got
Silicon-
silicon.
Sand.
Silicons and oxygens and stuff like that.
Sand.
Yeah. And so anorthosite makes up most of the lunar crust, actually. And I'm going to go with basalt.
Oh. I would have sworn you were going to go with an orthosite.
I know, that's why I went with basalt.
Yeah.
Only
But-
because I've been to Hawaii and hung
Picked
out with
up some
basalt,
basalt,
and
yeah.
it's also interesting, and it indicates like different processes happening later on in the moon, so it's pretty interesting too.
I have some sort of, what's the word?
Mental block.
It's something like that. I was going to say something more self-deprecating and severe than mental block, like a malfunction
In your
when
brain.
it comes to things like anorthosite.
Mhm.
I have looked up anorthosite 5,000 times in my career, and it just won't stick. And as every time I
Oh,
read it,
weird.
I start seeing igneous and plagioclase and feldspar and
Mhm.
ilmenite, and then it's like I'm talking to. It's like in that episode Spock's Brain of the original series. After the teacher wears off, you don't know what you're doing anymore.
Yes.
You'll have to go check out that episode. One of the
Yes.
classic.
They're both igneous rocks, so they're both
Are they
produced
both
by
igneous
volcanic or melting processes.
Okay.
Yeah.
Okay.
So maybe that'll help.
Maybe that will. Today, we're talking about neither Cherenkov radiation nor anorthosite, but star formation,
Cool.
fast and slow.
Okay.
Right?
Okay.
And there's all sorts of interesting space news. But first, this episode of Walkabout the Galaxy is brought to you by Blackbody Radiation.
Ooh.
Don't be deceived by our unassuming name. Blackbody radiation is the brilliant illumination that brightens your day. For stars, planets, asteroids, and even people, Blackbody radiation provides a simple one-stop shop to describe the spectral radiance. Give blackbody radiation a temperature and we'll give you photons from gamma rays to microwaves. Blackbody radiation also provides an excellent return on your investment. Double your temperature and will deliver a whopping 16-fold increase in your radiation return. Blackbody radiation, get more.
Okay. I'm teaching blackbody radiation to my students in class I was supposed to do it this week. It'll be next week now.
Okay. Get
Yeah.
more.
Get more.
Get more.
Get more.
That's just so general. It could be anything. I
It
don't
could be
remember.
anything.
King size Snickers.
As good a guess as anything. T-Mobile. Who knows
Oh.
why?
Yeah.
I
Is
have
that
no
still
idea
their
why.
motto? I feel like it's.
I don't think so.
I think it's but that does sound familiar.
I think it's maybe their motto now is we're purpley pink or something like that, because that's the only thing I associate with them. Space news. So there's all sorts of things going on.
All sorts of launches and tests and all of this stuff happening.
Right, yeah,
It's
we'll
very
start-
exciting.
we'll
I think
start
it's
with some of
because
the
it's like
tests.
we're getting close to the end of the year and all these companies are supposed to have demonstrated stuff by the end of the year, and so they're like, we got to do it now.
Yeah, maybe so. Let's talk about the tests of the Boeing Starliner.
Boeing Starliner did one test already, so this is their crew capsule for
Right, it's
Going
their
on.
version of SpaceX's Crew Dragon.
yes.
So, and they've actually already announced that first astronauts that are going to
Mhm.
go up on this
Mm-hmm.
to the International Space Station. So this is the gumdrop thingy that goes on the top of the rocket, and the rocket that this goes on top of is what?
The SLS maybe, or
Is
a
it?
different one?
It's a ULA rocket, I thought. No, isn't it?
Oh, maybe.
Yeah, United
We
Launch
just
Alliance.
talked about this the other
But it's
day,
not a
and I forgot
SpaceX
which one
rocket
it is.
or a Blue Origin rocket. It's some other rocket. But this is just the capsule. So they did their emergency abort test, where
Yes.
they basically had the capsule itself fire its escape rockets that are meant to pull it away from the rocket if the rocket is exploding on you.
And they also did a parachute test
Accidentally.
like a week ago.
Oh, but this one also was accidental.
No, they were supposed to be doing a parachute test, but it didn't work quite right.
Oh, well, So okay, maybe we're both talking about the same thing.
I think so.
So
they did a parachute test.
In the crew abort, in the abort test, only 2 parachutes deployed, but 3 were supposed to.
Yes, and they think they've identified it was like a pin wasn't in place for the third one or something.
So they sort
like
of
that.
accidentally tested that it survives a landing with 1 parachute not working.
Yes, it looked like a pretty firm landing.
Yeah.
But it was a landing.
It would be a landing you could walk away from.
I don't know, the landings in of Soyuz in Kazakhstan or wherever they end up landing look pretty
smack
intense.
into the ground.
Smack pretty hard.
Yeah.
There's also supposed to be another SpaceX abort test pretty soon.
Right.
Because they had a malfunction.
They
did an abort test and it went well, but then they were retesting the engines and the thing blew up.
Right.
Not
Whoopsie.
Great. Oops. So they're going to test a different vehicle
right.
Again soon.
SpaceX is also getting ready for their first sort of non-test version Starlink launch, I believe, any day now.
Monday.
60 November 10th or something like that. 60 new of these
Starlink
little satellites to provide internet service out of hundreds or thousands, and we've talked about the implications for those. So they're getting operational with those. Another bit of space news up your alley that's related to an orthosite and basalt. Do you know what I'm talking about?
The moon.
Yes. And more specifically, they decided to open up.
Oh, yeah. Well, it wasn't just they randomly decided. So back 6 months ago or something, right, there was a selection of scientists who were going to be able to analyze a bunch of samples that had never been opened before.
Yeah.
And so they're finally starting to hand out those samples.
Right.
And so they opened up samples that had been in their closed sealed containers since we brought them back
almost
from the
50
Apollo
years.
mission.
Right. Yeah.
So they're starting to
These are
open
from
them up again.
the last 3 missions, 15, 16, and 17.
Yes.
I think.
I think that's true.
And the idea is that back in the early 70s, they said, well, let's hold on to some of these things because maybe we'll have better tools and techniques in the future, which was good foresight because guess what?
Yeah. And I mean, the rest of them that have been opened are still stored, when they're stored at JSC, they're still stored in really, it's a nitrogen purged room and they keep it really dry and all that stuff, but and they only give out small samples at a time anyway, but these are samples that have just been completely untouched and still sealed from when they were brought back.
Right. And when they do send them out, those samples, because you may have worked with some in Colorado, and I saw some of those dust samples from the moon
that we had to keep
Colorado,
in a safe.
That has to be, you have to have a plan to keep it secure in a safe because it's not legal for any of it to get out in the world. And then when you're done with it, you have to send it back to JSC.
Except when you use dust, you're like, sorry, we can't send all of it back.
Right. So
are there samples of lunar stuff just out there that you can buy in the public?
Only if it's a lunar meteorite.
Technically, they're supposed to be from meteorites. Technically, there's not supposed to be anything that was brought back from Apollo that can be sold. There were samples, a few samples that were given as gifts to governors and politicians and stuff like that. But
and there were some, at one point, somebody did steal something and put it on eBay or something like that. That didn't turn out so well for those
he
people.
Is in jail.
Yeah.
He did have a pretty good night, though. And then
one good night.
At least one good night, and then he went to jail.
Here's another bit of space news I thought was amusing.
Okay.
Jim Bridenstine, NASA administrator.
Is this going to be about Pluto?
Yeah.
Yeah.
So he's
tired of it.
He's just decided Pluto is After all, Pluto is a planet.
Yep.
And what I find amusing about it is that
he doesn't
get to decide that. Nope.
I don't know. I think everybody just make your own decision. So if you want to.
That's not how it works.
Well, with planets, it seems to be because everybody is sort of making decisions.
Yeah, I mean, I think I'm just tired of the whole debate centering around Pluto. I wish it would be a more productive debate that would just talk about all of the different bodies that are out there.
Well, I'm fascinated.
I just get so tired of hearing about it.
I'm fascinated by why so many people care so deeply about it.
It's just it's weird, right? But people really were upset when Pluto was demoted.
Right.
And people were real upset by that.
So first there's the concept of demotion. So there's this concept of hierarchy, star is better than planet, is better than dwarf planet, is better than comet, is better than asteroid or whatever.
Yeah.
And which first, I don't even buy into that idea, right? And then second, let's just talk about Pluto. The mission is amazing, the pictures are amazing, it's a super cool place.
Yeah.
Great. I don't care. Call it what you will. Says I. Let's see. There is a we've talked a few times about how we might see life first around elsewhere in the universe. What are your bets on like how we might first get note of extraterrestrial life?
Signals.
Oh, really?
Communication, like in the movie Contact.
Really?
Gonna happen.
Is that what you really think?
No. That's what I want to believe.
What do you think?
No, it's probably going to be, we're going to see some large amount of
Micro.
oxygen in an atmosphere.
Yeah.
Do you think it's going to be something like that or something here, like in the solar system?
Oh.
Yeah, well, that's the
Like,
other
are we talking
alternative.
about
Is like you
intelligent
find
life or just
no
life?
life at all, and it doesn't need to be like so. Fossils on Mars would count.
Yeah. I bet that we first do find some atmosphere, because we're starting to do that at a much greater rate. So I bet we find some atmosphere that has oxygen. Of course, that's not for sure. That's just like a strong hint that there may be life.
It's pretty strong.
It's pretty strong, but not, there are some chemical processes which could produce, for short periods of time, and
yeah.
But anyway.
So that's I also think that, and I guess I also wish that it were the other one.
Yeah.
I kind of think we're going to find something on one of the
In Mars?
Icy moons or something?
Mars or one of the icy moons. It's just like the problem is that it's so hard to tell if it's something we brought or if it's something native.
Well,
if
it
it's
won't
like
necessarily
if it's
be
like
hard
a
to tell.
chemical if
Right,
it's chemical detection.
It may not be hard
right?
to tell.
If it's like
If it's radically different from Earth life.
Yeah.
Or if it fossils on Mars.
If it's a fossil or something, sure.
Right.
Yeah. There's not going to be fossils.
Or, if you fly through
To
the
make
plumes.
fossils, right, you have to have had life evolve to a high enough level that it's got something that is going to make fossils, right? So discovering like a microbe on Mars is completely different than discovering a fossil on Mars. And I feel like discovering like microbial type stuff is way more likely than
Yeah.
or like formations that were due to microbial stuff. So like that, it's like stromatolites are a thing here,
Right.
If you see something like that maybe has been fossilized, okay, I can see that.
20 years ago or so, when there was a little bit of a hubbub over a Martian meteorite, ALH 4001 or something like that, a meteorite that we knew was a rock that had been blasted off Mars and made its way through interplanetary space and landed as a meteorite on the Earth. And they know it's from Mars because of elemental isotopic ratios trapped in the rock. Then they looked at it and they're like, ooh, here's little things that look like things we see on Earth that are caused by life.
Mm-hmm.
And turned out probably not so much.
Yeah, that's why you gotta be super careful.
Yeah. But in any event, the reason I bring this up, the reason I ask that question is because there's a European mission scheduled for launch in 2028 called Ariel, like the Little Mermaid.
I was gonna say, does it have
That's
red
an
hair?
acronym, and it's one of these terrible acronyms for atmospheric, so we're okay there with an A. Remote sensing, that's the R.
Okay, that's fine. It's hyphenated, I'll allow it.
Infrared,
Okay.
exoplanet, which is good.
Okay.
Then the L is large survey.
Yeah, seems like there's a few S's in there that they decided to skip.
Yeah.
They could have just called it atmospheric remote sensing infrared exoplanet survey, and then it would have been Aries. But maybe
which would
that's
also
too
be
many
good.
other things or something. I don't know.
Who knows? Anyway, NASA's contributing an instrument to that mission called CASE, which is an acronym with an acronym within it, because
Is it like lights?
the A in CASE is the Ariel,
Oh.
and the C is contribution. So it's really stupid. It's something like contribution to Ariel for
Spectroscopy of exoplanets. That's real bad.
Yeah. Anyway, this is a telescope specifically designed to look at just what you were talking about, which is the spectral signatures, the signatures in the light shining from a star through an exoplanet's atmosphere, where maybe we would be able to see oxygen or something like that. So it could be.
So here's
could
the
be
thing about that, though,
2028.
right? Is that like most of the atmospheres we've seen so far are from huge, big planets,
Yes.
like exoplanets, like Jupiters or even hot Jupiters, and like those aren't going to have oxygen.
Well, if they did,
They
that'd
did,
be pretty
that'd be
exciting.
Yeah.
But,
You can imagine life in
Yeah,
possibly
did you
in
see
places
the
like
original
this.
Contact? All those big floating fish monsters.
did you say the original Contact?
I said Contact and I meant Cosmos. You
That makes more
you
sense. I
should have
did
known
realize
that.
that as I was asking the question. I thought maybe he meant Cosmos. I have
did.
seen the original Cosmos.
I said Contact because my brain is not a steel trap, and he said Contact 3 minutes ago.
And they're both by Carl Sagan.
And they both involve Carl Sagan. That's right. They
The
both are
Contact
by
book is
Carl
written by
Sagan.
Carl Sagan,
Yeah.
One last bit of space news before we move
Space
on.
news.
First
about the
light
moon?
for a cool astronomical observatory experiment thing called DESI, which is
Is that an acronym?
It is an acronym. It's DESI, which is a reasonably straightforward acronym. It's not crazy. It's just it's the what is it?
There's one called
Dark
Lucy, too.
energy something
Right.
instrument. The dark energy something instrument.
Spectroscopic instrument.
Right. Dark energy spectroscopic instrument, which is a instrument placed on a pre-existing telescope, one of the ones out at Kitt Peak in Arizona, outside of Tucson. But they took one of the big telescopes out there, a 4-meter telescope or something, and put this experiment onto there, or an instrument designed to look at many, many, many different galaxies at the same time, like 5,000 galaxies at a time, for like 10 seconds each. And it's going to over the course of a few years take the spectra of 30 million different galaxies in our neighborhood.
That's a few.
That's a few.
And I'm guessing that it's able to look at, what'd you say, 5,000 galaxies at a time, but it's basically just looking in one direction.
Right,
but you're zoomed
any
in,
direction you look,
there's a gajillion
There's 5,000
galaxies.
galaxies there.
Right.
I mean, it has a wide field of view, and so that it's looking kind of in one direction, but it's looking at
Right.
5,000 different galaxies all at the same time, and each there's like 5,000 different little circles
Smudges.
that each one is connected to a fiber optic cable, and so the light from each galaxy gets separately put into each fiber optic cable.
Oh.
And then you look at all 5,000 of those at the same time, and so obviously producing huge amounts of data and stuff, and that's probably the hardest part of this experiment is figuring
Right.
out what to do with all the data. But the idea is we'll map out the nearby and not so nearby, but a pretty big volume of universe.
In a sort of wedge going out? or
Yeah,
the
and a kind of it's a survey, and I don't know, but they're trying to get pretty deep, so they should be able to get to redshifts of 3.5 or something like that for some quasars. So they're going to be looking at nearby things, middle distance things, and large distance things that I don't know.
A redshift of 3.5 is like 12 or 13 billion.
Yeah,
light years
these
away.
are stuff that are very close to the edge of the observable universe.
Right.
So we'll be able to do all this mapping, and mapping out the universe is a really nice way to figure out whether there's dark matter or dark energy or not, or what its behavior is, because I can see we get a better idea of whether the universe is expanding faster today than it was back then by looking at the structure of the universe today compared to how it was back then. So that is just now been turned on, and they're done first light and then showing some of the first spectra coming from that, and the real science mission should start any day now.
Cool. Yeah.
Yeah, that's one of the things we talk a lot about, new instruments that are being built and new satellites and spacecraft and things like that. But like for ground-based telescopes, most of the advancements come not only from building new telescopes, but from putting new instruments with new capabilities
right.
on existing telescopes.
That's right.
Because you have the optics there,
Right.
but then you have different instrumentation to do different types of measurements.
right.
So like
You get-
South Pole Telescope, they put different instruments on all the time to get a lot of the cosmology stuff we talk about, or Kitt Peak, or
Yeah, this is kind of cool
Hawaii.
because Kitt Peak. This is in Arizona. This is not that far from Tucson. And this is not the greatest telescope on Earth, or anything, right? It's 4
Right.
meters, and it's in an area which is not nearly as good as the
Mauna
Chilean,
Kea or
the Andes or whatever. But still, it's useful, right? Put one of these new fancy super awesome instruments on there, and all of a sudden you have a thing that's able to measure the positions of 30 million galaxies over the course of a few years, and
Right.
and do some serious science. So that's pretty awesome.
Cool.
yay.
There's actually one more little thing I'd maybe classify as transitional space news, science news.
Okay.
And then we'll do our trivia, then we'll do our actual science thingy.
I
Whatever
mean, it's all
that
been
is.
actual science.
It's all been sort of actual science. We haven't had nerd news today.
No, we've been
The
skimping out on that. We
Terminator
should.
movie is out.
Oh, yes. Have you seen that?
Not yet.
We're going this weekend.
Maybe this weekend,
All
yeah.
3 astroquarks are going to go see that this
Oh,
weekend.
Yay.
that sounds good.
Yeah,
What's it
on
called?
Sunday. I don't know.
So
Terminator.
But the idea behind this Terminator movie is, how many Terminator movies have there been? 17?
Yes.
Something? And so there were 2, the good ones,
Dark
that,
Fate, I
that
think.
James Cameron made.
Yeah.
And then there was some random weird series of sequel slash reboot slash retelling slash alternate timeline, and then apparently this one is just like 3.
Yeah.
Right.
Yeah.
Pretend that everything that happened after 2
I didn't
didn't
think those
actually
other ones were
happen.
that bad. I enjoyed
They
the other
were-
Terminator movies, but they just
yeah.
weren't as good as the original 2.
And yeah, I actually
The flavor of them
I
was
saw
different.
some number of them and enjoyed them to varying degrees. but I sort of lost track of what the hell is going on
Right.
here.
Yeah.
I
Right.
mean,
And that happens
how-
every time they do stupid time travel crap. You lose, 'cause you're
Well,
like
yeah,
allowed to
like
change the rules whenever you
changing the
want.
rules,
Right.
Same thing
changing-
happened with the Star Trek thing. I lost track of what was happening.
Which one?
The new Star Trek.
The new Star Treks, where they like
Oh. Yeah.
They
Oh,
did
you mean
all
like
that.
the so-called Kelvin timeline?
Yes.
I don't know, yeah.
And now I
Yes.
guess apparently we just like pretend that never happened too.
Oh, really?
Like those 3 movies are just like orphaned
They're their own
on
thing.
their own.
Is there a new Star Trek movie coming out that's going to be back on the original timeline?
There was going to be one. My understanding is that there was going to be a new Star Trek movie that was going to close the Kelvin
Oh.
timeline, and then everything
Reset
would be
it?
consistent with the original
Uh-huh.
William Shatner timeline, for lack of a better word. But then there were just like contract disputes, and people just didn't agree about it, so they just like
lame.
let it go.
Aw.
So that's my. I'm not 100% sure I've got all that right.
All right.
Yeah.
Anyway.
I started rewatching The Expanse in preparation for season 4 to come out.
Okay, cool. That's a good show.
It's so good.
Yeah. And it's about
Highly recommend.
asteroids.
It's about
The only way Addie would like it better is if it was on the moon.
there's not really there's only brief references to the moon, but it's about
That's the one flaw.
future civilization and living in the future, and it's a very good drama, and it's some sci-fi.
Yeah.
And they're on Mars sometimes.
And they do their science reasonably well.
They do.
Yeah. Yeah. Well, I'll tell you what. So, this last little bit of science news was the Voyager 2. Earlier this year, late last year, they said, hey, Voyager 2, which was launched in 1977, one of 2 Voyager spacecraft. They were launched within a couple weeks of each other to explore the giant planets. Miraculously have kept working.
I cannot
all
believe
these
we're still
years.
talking to both of those things. We've
40
said this before, but it's crazy.
40 years on, they still work, and they've been sending data back. And Voyager 1, 6 or 7 years ago, crossed what we call the heliopause, the sort of boundary between the influence of the sun's magnetic field and charged particle stream and out into the realm of interstellar space, where the particles you're running into, the magnetic field you're running into, are coming from other stars and not from the sun.
Yeah.
And last year, that seemed to have occurred for Voyager 2, which was going in a different direction and somewhat slower, and a bunch of papers came out. Voyager 2 is now also outside the solar system.
Yep.
And there were some things they saw that were consistent with the first crossing, and some that were a little bit surprising to them.
Part of the surprising thing was that it was pretty consistent with Voyager 1.
Right.
So they went out in different places in the solar system, but also at different times in the solar cycle.
Right.
So we expect that the solar cycle influences sort of like the distance to where sort of the heliopause or the edge of that
Right.
region is. And it seems to be at within
didn't
like
make-
5 or 10 AU of each other, which is like a pretty close.
It didn't make a big difference, the fact that one was going when the sun was sort of breathing out and the other when it wasn't breathing out, kind of. Yeah.
It was pretty cool.
So Voyager, my dissertation was on Voyager 2 data.
It's pretty exciting because it's
From
plasma
Uranus and
instruments.
Neptune.
Are they
that telling us
still
all
like?
this stuff.
Is NASA still funding that, or is the government
Well,
still funding? I mean, if
yeah.
people are still looking
They're
at
funding enough to at least like use the DSN
yeah.
to talk to them,
Yeah.
right?
DSN
And
is the
Deep Space Network that we use to.
Right.
Yeah, that's a
Telescopes that we use.
super faint radio signal coming from these things that are
Yeah.
110, 120 times further from the sun than the Earth is.
right.
So but there's not like a team sending it commands still, or is there? Or are we just like passively receiving signals at this point?
I imagine that it's on a sort of automated sequence,
Yeah.
where every so often it transmits data back to the Earth, and it's regularly making measurements of charged particle densities, and it has a bunch of different instruments that measure different sorts of charged particles. It has a magnetometer that measures magnetic field. Hang on.
Does
How many-
Josh know?
How many stars are formed in the Milky Way each year? It's I know it's a number that begins with 1.
Okay.
It's roughly 300 suns worth of stars per year was one.
Is that what something
That's
says?
what this one thing says.
Okay, then I would say
In
The
the
Milky
Milky
Way
Way
forms just 1 or 2 solar masses each year, but this other one is about
Right.
300.
So the answer
One.
was 1, right? So
About one.
in the Milky Way. I mean, that doesn't seem like a lot,
That
right?
doesn't
so
seem like very much.
the Milky Way forms about 1 star's worth of stars per year.
Now,
Now, of course.
we're 12 billion years old.
Right.
We're not as peppy, not as virile
Right.
a galaxy
So,
as
yeah,
we used to
clearly
be.
when the galaxy was younger.
Is that a joke about the virial theorem?
Oh.
Oh, physics joke.
No,
No.
it was a sex joke.
Oh, that makes more sense.
But yeah, so we suspect that when galaxies are young, they have generally higher rates of star formation because there's more gas and dust to do that stuff. Except in galaxies where they have a really super active black hole
And
that
it's
sweeps
blowing
away
it
all
out.
that stuff.
Yep.
But I guess we have recently seen a galaxy that is doing what Addie just said, that is making stars at a rate of something like 300 solar masses worth of stars per year, which is something
younger
we
galaxy.
kind of expected
Right,
but
'cause
hadn't
it's-
seen. But yeah, it's a young galaxy, so that is. But of course, if you want to see a young galaxy, where do you have to look?
Back in time.
Back in time.
Back in time. So yeah, you have to look very far away, which means they're hard to see because they're.
Blah, 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 blah.
Yeah.
Something.
It's the same story over and over and over again
Yeah.
with
Yeah.
physics
What?
and astrophysics. Got to look a long way away to look back in time, and it's hard to look a long way away.
It is hard.
It
It
is.
is hard. But we're getting so much better at it. This is
We
the cool
are.
thing. That's why we're in this
That's why we have something to
golden
talk
age
about.
of galaxy study and cosmology study and stuff like that, because we can finally see reasonably well. And that's another thing that the James Webb Space Telescope, of course, is going to do for us, is give us an even better view of a lot of these very distant
So-
objects.
And this is also with ALMA, which we've talked about a bunch in terms of like
That's
protoplanetary.
This big great telescope in Chile.
Yeah, we've talked about it for other observations of like protoplanetary disks and stuff and stars. And
So the star formation in like the Milky Way is gradually petering out, right?
Sure.
Yeah.
And it's petering out. It's another sex joke.
It didn't have to be. It didn't have to be, Josh.
It is, but it didn't have to be.
And
It's colloquially become a different thing.
and because the material in the galaxy is gradually
Getting
getting
used up.
locked up and put in boring things like white dwarfs and neutron stars and black holes. And
White
not-
dwarfs aren't that boring.
No, I know they're cool. They're all cool, but I mean it's like not
Pretty
available to be turned into new stars again.
Yep.
Some
Yep.
stuff gets blown out there, make new stars, planets, people, but some of it gets locked away. So
Yeah.
eventually this stuff stops blazing away.
Yeah, yeah. I mean, it turns out, though, I mean, you're going to have to wait a really long time before star formation ceases entirely, right? I mean, the amount of stuff out there is huge. When you really get yourself into trouble is, like we said before, when you blow out all your material into intergalactic space and you've lost it, and entirely.
So, and is there?
It's not
is
a
there,
good strategy.
So why isn't that?
Self-preservation.
Why doesn't that happen with like the Milky Way? How come our supermassive black hole isn't doing that?
Well, it's kind of, it has eaten the stuff that is available to eat around it, and so it's not currently, there's not very much stuff falling into it, which means it's not producing these winds to blow
Right.
stuff out. It probably had, if you went back billions and billions and billions of years ago when the Milky Way was younger, it probably had a significantly more active thing, and or more active black hole, and
Right.
we could have had even more stars if we had not blown out a bunch of stuff earlier.
Dang.
I know.
But
But 400 or 500 billion is not enough.
It's not enough. We need more.
I did see an article that said that the activity of the Sagittarius A star, the supermassive black hole in the Milky Way, is lower, perhaps now, sort of anomalously, because of something weird going on with the galactic magnetic field.
Oh, weird.
Ooh.
Something that we'll talk about.
We'll have to read
perhaps
more
on
about that and talk
on
about
a
it
future
another time.
episode.
Hmm.
Yeah.
All right.
Sounds fun.
So star formation is what we kind of all counted on to be here in the first place. So it's interesting
Yeah.
to hear about how that varies across things.
Thanks,
so
star formation.
maybe we can reach out to
Yes.
them to sponsor an
Yeah,
episode.
that's what I was thinking.
Yeah. All right. So what are your thoughts on which
Oh.
of the following messages is not on
Oh,
the
yeah.
golden record that has been sent out as
What-
the one of the few permanent relics of human civilization and existence into the galactic void? Your choices are you well? Hello, everybody. May you live long and prosper. Hail. Good night, ladies and gentlemen. Goodbye and see you next time. That's one.
Okay.
And hello, how are you? That's also one.
What was the first one?
Are you well?
Okay.
I don't.
There's a certain lack of imagination in most of these.
Yeah, yeah. I mean, I guess you got to make it simple. Were these all? I thought
They were
they were done in
recorded
a
by
bunch of
different-
different languages.
They are.
They're
55
different languages
different
and
languages.
different people suggested them
Yeah.
and stuff
Yeah.
like that.
I'm gonna go with the Goodnight one, even though I feel like it's long and complicated, and you probably wouldn't have put that in there as a fake choice. But I'm gonna go with it anyway because
Oh.
it sounds weird and dumb.
Uh-huh.
What was the second one?
Hello, everybody.
I think it's that one.
Okay. I fooled you.
Oh.
Got both of us.
Yeah, I did. Actually, it was
Is it
the Star Trek one. Yeah.
I was trying to think of the timeline and if it was
It was in
Star
the
Trek
70s.
would have been out.
Oh, yeah.
But
Yeah.
It could have been. That's
could
why I
have
said
been that
I had to
one.
put that in there. May you live
Yeah.
long and prosper. And I put that in there because most of them were basically saying that.
Yeah.
A lot of the ones I didn't list were just like, hope you're well, good health to you. They're remarkably uninteresting. Good night, ladies and gentlemen. Goodbye and see you next time was in Indonesian.
Oh.
Hello, everybody.
That's bizarre. Next
is-
time.
Yeah.
Next time you capture one of our spacecraft.
I don't know. Good. I just love the good night, ladies and gentlemen. Hello, everybody was French. Hail,
Hail, Caesar.
Hittite.
Oh.
Are you well, Burmese? Hello, how are you? Which seems like an awfully polite thing to say
Mhm.
from the Japanese. A couple other ones that I thought were hilarious were in Mandarin. Hope everyone's well. We are thinking about you all. Please come here to visit when you have time. And I was like thinking maybe when they reached out to the to get that particular one that they misunderstood what was being asked because it sounds like the thing you say to your great uncle or your your brother's
Yeah.
parents-in-law
Not-
or
not
something like
aliens.
that.
Not really.
Yeah, I hope you're well. We're thinking about you. Stop by and
Stop by
visit but
sometime.
when you have time.
When you have time.
When you have
no
time.
rush.
No rush. It's all good. Let's see. In Rajasthani, hello to everyone. We are happy here, and you be happy there.
Aw.
Which is sort of like
That's like, don't come.
don't come visit. Yeah. And then finally, dear Turkish-speaking friends, may the honors of the morning be upon your heads.
Unlikely that they're going to be Turkish speaking.
I'm sort
Well,
of
if they
disappointed you
understand
didn't
it.
read those in their native tongue.
Oh, that would have been good.
Maybe we can have our listeners respond with some of those in the correct pronunciation.
Well, let's hear it. There are 55 of them out there in 55 different
Perfect.
languages.
That'd be
We
fun. We
must
can make a
have listeners in all
Walkabout the
55
Galaxy
places.
Voyager reading compilation
There we go.
from Walkabout the Galaxy listeners.
Well, it may have felt like the time for astronomers to decide what's a planet. It was just another episode of Walkabout the Galaxy. If you liked this episode of Walkabout the Galaxy, write us a review by taking a midnight canoe trip in the shallow coastal waters of Florida and trace it out in the bioluminescent plankton with your paddle, capturing it by video with a drone. Also cool to write one on iTunes. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walkabout the Galaxy, where you can count the Star Trek toys hiding in the background. Catch up on old episodes wherever you get your podcasts. Thanks to our listeners in Virginia and around the world. Follow us on Twitter.
At walk_the_galaxy.
Ask us questions anywhere using hashtag #WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Our production assistant and video guru is Diego Rodriguez. I'm Josh Caldwell.
I'm Addie Dove.
I'm Jim Cooney.
We're the astroquarks signing off until the next episode of Walkabout the Galaxy.
Klaatu Barada Nikto.
Nice.